Hello and welcome to the OLM Dev Working Group. Today is Thursday, June 2nd. On the agenda for today, we have a presentation from Nico on the package operator prototype. Nico, would you like to go ahead?
Yes, sure. Can you hear me? All right?
Yep.
Nice. First time using Zoom for like 2 years, so this will get interesting. Oh, and I got muted. So, good evening, good morning, or whatever is appropriate to your time zone. I'm here today by invitation from Nick, who just joined, which is super nice. Showing off a little prototype that I've made about a year ago. So let's get started. Oh, wait. I'm sharing, right?
Yes, you are. Maybe it's I don't know. I'm 3 minutes late, Nico. I don't know if you've had a chance to kind of introduce yourself and just go over the motivation for showing off the package operator. But you haven't.
That's what I was just about to do.
Okay.
Why, what, and who am I?
Okay, go for it.
All right. Perfect. So first time coming to this call, so kind of excited. Who am I? I'm Nico Schieder. I'm a senior site reliability engineer at Red Hat, and I work on add-ons in managed Openshift. Add-ons in managed Openshift are kind of extra components that you can add to, well, a managed Openshift cluster, which is completely under SRE support by Red Hat, and well, Red Hat branded in SLO and under tight SLOs. What I'm showing today is a little pet project that I started about a year ago, trying to implement a few features that are not available in OLM. And the reason for that is so add-ons keep multiplying. It's kind of the thing on the very right. So for every managed OpenShift cluster, and fortunately we have a lot of those already, there are multiple add-ons being installed. So if the fleet size grows, we get more and more work to do in our little team. And that means that we have to be really careful to automate a lot of things and to reduce negative impact of rollouts as much as possible. And to do that, I have a long wish list for OLM, on the future for OLM. And before I tried bothering people without any context, I tried, hey, is this even feasible to build something that would tick those things off my wish list? So for my wish list, I kind of, well, declarative APIs, which I think is already very much on the roadmap for the new APIs for OLM. I would like cheaper failures and an easy recovery, because we have a lot of teams that just start out working with operators, and when they push things to prod, it might not always work, right? Incremental and controlled rollouts, so things get rolled out step by step. Think about it. You first need to install custom resource definitions, then you might boot up the first components, then you do a database migration, and it takes a while to finish, right? So there's kind of a controlled process. I also want rollbacks because, well, we have to face it. Sometimes things go wrong, and the easier it is to get back to a functioning state, the less worry I have as an SRE in the middle of the night to get stuff back to operation. Extensibility, something that is super nice, because we have so many new projects coming around Kubernetes APIs. It's sometimes hard to get them into bespoke APIs in OLM, for example. when we have new auto scaling or fleet management mechanisms, then, well, it takes a while to get those features in. And I, like, for my wish list, I would like to have something that is just working out of the box with things that it didn't know before about. And observability transparency, which doesn't really mean the usual thing of tracing and metrics, but more on the level of, hey, can I just look at a few objects in Cube and actually understand what's going on the cluster, right? Then low barrier to entry. I think with OLM especially, there's a huge chain of dependencies that you need to master until you actually are able to deploy something. And I was thinking it would also be nice if that could be slimmed down as well. Well, and last but not least, easier time scaling operators, which is also becoming interesting when we think about, well, I will come to that later. Essentially, what I really want is I want deployments for arbitrary things, something that is coordinating a rollout, rollback, and that makes it very cheap to get, well, something on a cluster in a controlled manner. To get there, I was first thinking, hey, introducing the package set. So that's essentially just, and I come to a demo where I show everything in action, which will be way nicer, but just to get the concepts down. I was looking essentially at deployments, and a deployment, you have the pod underneath, then above the pod you have the replica set, and above the replica set the deployment, which is handling rollover. And I figured, can we make this more generic for things? So the first thing I've implemented was, well, a package set, which is just an object that is comprised of multiple objects, and it's applying and reconciling all of them as kind of a group. It aggregates the status back. So, well, higher level operators can make sense of the group of objects, and it's immutable, similar to, well, a replica set. It can be scaled back to 0, so it's archived, so it's still around in the Kubernetes API server to go back to if wanted. And it does things phased, so it would first, well, it does things in an orderly fashion instead of just dumping everything at once against the Kubernetes API server. So how this looks in practice is kind of within with phases, is within this package set. You define a phase and put a few objects in there, and probes how the package set controller can make sense of those objects. So a very simple example here would be that in the first phase, we install CRDs, and we make sure that all of these CRDs that we apply to the cluster have the condition established set to true before we continue into the next phase. And then go into deployment phase. And if the deployment succeeds, and the deployment phase just has a single deployment object, and this phase succeeds when, well, all replicas are available or updated. And for deinstallation, we could run those phases in reverse to make sure that that's also done in an orderly fashion. So if, for example, the next phase would be a database migration or something, this migration could be rolled back as well, depending on the semantics of the operator or whatever thing you're deploying, really. It doesn't really need to be an operator in the end. Yeah, so kind of first this stuff gets ready, ping, ping, then the whole phase gets a checkbox, and then deployment gets reconciled, and this phase is ready. And now, well, this is nice-ish, but what to actually manage those things, a deployment is way nicer for user experience. So what a deployment is doing, it's handling handover between and rollout of package sets. So if you have a revision 1 of your package running on the cluster that's reconciling things. What the deployment will make sure is it will create a new package set with your new specification, wait for it to be reconciled, and then it will tear down the old revision. So similar to what you do when you edit a deployment in Cube. It will set up a new replica set, wait for the new replica set to come online. And only when it comes online and is in a state considered ready, it will tear down the old set, which, just speaking from S3 perspective, is really nice because it makes it very cheap to deploy something that is broken because, well, the old thing keeps running and serving requests in the meanwhile. Now you might ask what to do with something like a custom resource definition, because that's not something that you can tear down when you switch revisions. So for that, there is a handover process in place. So objects that are referenced by both the package deployment will coordinate that first the package set revision 1 will stop reconciling the custom resource definition before revision 2 will take over. And that's kind of for all shared objects. So there's always a single thing, right, in control, a single controller in charge. And then, well, and then it can make its changes. And if we roll back, well, the same thing would go in reverse for rollback. Should I go through questions first, or can I go to the demo? Because I think that will make things way clearer.
I think there's some conversation happening in the chat, but why don't we go to the demo and we can start going to the questions once the demo gets over.
All right. Wish me luck that the screen share is working. You should see a terminal window now. Yes.
It's all dark. Oh yeah, we see it.
Okay. I hope it's readable.
It is for me.
Okay. So I have 3 tabs here, and in the bottom I will do my commands. On the top left, I will watch the deployment objects, and on the top right, we will see the package set objects that are created underneath. So quickly go there, start. So first, we will roll out a simple engine export. To make this larger. So this package deployment has a single phase, deploy. Deploy will create and reconcile 2 objects on the Kubernetes cluster, one config map, nginx v1, and nginx deployment v1 with an engine export. And I have 2 readiness probes defined, so the controller can make sense of whatever kind of object it's creating. So for all deployments, it's checking whether the available condition is true and whether updated replicas is equal to, well, replicas. Make sure that the rollout is succeeded. There might be better ways of checking that and probing it, but this is easiest thing I could come around with the fields available. And now if we create the package deployment, pending, progressing, it's not ready right now. The package set is created and available, nice. And we see 2 pods are running. So this rollout worked, which is quite nice. Because the probes are reconciling, and like the whole operator is set up like a usual operator would, so everything is watching the resources that we just created. I can now go here and delete. Can delete all the pods, and what we should see is that not ready, ready, that the status is reflected back into both the package set object and the package deployment object, depending on the underlying workload. In this case, it gets the pods get recreated kind of quickly, but if a node would fail, for example, this might take a little while, depending on the application. It's really useful for me as an SRE, if I look at the cluster, to see directly the state of something top level. It also means that what we've seen sometimes is that we actually try to roll out a release and the new release fails after a little while. So initially it looks all right, but then 10, 20 minutes afterwards, it gets OM killed, for example. And when we track status all the time, we can also automatically roll back, for example, with a timeout without needing an SRE to wake up in the middle of the night and fix things. So what now if we upgrade something? So showing V2. So I'm patching the same package deployment object. I'm creating a new config map, nginx v2, a new deployment, and there is a new readiness probe defined for kind config map, making sure that it will only continue when the annotation test is set to the same as key 1 in the config map. So if I roll this out, we will see the deployment get back to progressing. It created a new package set, which is not ready until the new deployment, the V2 deployment, is ready. And any second now. Any second now. Crap, it's always when you do demos that something is not working. Give me a sec to restart the controllers. This worked like 5 times in a row without incident.
Yeah, that's the demo guard, right? But I think it also probably is an opportunity to highlight the fact that even if my upgrade isn't available yet, yeah, you know what I'm getting at, Nico.
Yes, okay, sorry, I'm just nervous and it's getting a bit late for me. This is actually expected. So it's not ready because if we check the status of the package set that is stuck not available, we see, yeah, the config map, so phase deploy failed, the config map annotation is not equal, or well, the annotation is missing in this case even. Let's change that. Test 1, 2, 3. Make sure that keys are equal. And nice. Now the new set became ready. The probe succeeded. And the old package set was archived. I don't have nice rollback implemented yet because that's usually like a client feature. But I could now also patch back the package deployment to roll back to the last revision. But now to something more interesting. Let's upgrade to something broken.
Hey, Nico, one quick question.
Sure.
So you were able to patch the config map. Why was that not reconciled back to what was defined in the package set?
It's a very good question. So right now, the reconciler is only patching known fields. So it will not override objects completely, which might not be what you want in the end thing, right? So usually it should like override the whole object probably, or the strategy to patch object might be configurable. I'm not quite sure. For the demo, it was necessary because I couldn't figure out another way to kind of show human intervention in the loop.
It's basically like a 3-way merge then.
Yes, exactly. Merge strategies can get really tricky here, especially if humans or the operator that you're deploying wants to still mess with annotations and labels, and maybe you have an autoscaler in the mix. Haven't quite figured that out in total. Is that okay as an answer?
Yeah. One thing that I think we've also thought about is, like you're saying, like cluster admins, like what's defined in a bundle or in a package set or wherever you're getting that from. That's not always cluster admins that are defining that. But yeah, like ultimately cluster admins should be able to control what goes on the cluster. So we've talked about like somehow there probably needs to be a way for them to inject their own patches that also get reconciled as part of applying these things.
Yeah, exactly. And well, stuff gets tricky the more things you layer on top. In this case, I tried to concentrate on the most basic stuff, which is just, well, dump something on the cluster and have it reconciling. So I rolled out v3 release, and well, that is hopelessly broken. Somebody messed up the tag, but that's no problem because the old release continues to be there on the cluster. So it's not ready. So now, and this is something that people find probably very very scary sometimes, is, well, I will roll out v4 now to, well, skip v3 in the chain. This might not be always what you want, but it's what I know I can do in this case. But v4 will also be broken because in here I added a dependency declaration. So what we should see if I upgrade to v4 is, okay, so the intermediate release v3 that was that never succeeded is now archived, and the package operator switched to going from the working v2 release to v4. v4 is also not working because, well, it's missing a dependency. And if we quickly check, and if we quickly check the status, okay, missing objects in Kubernetes API, the thing is not there. I have no CoolDB operator, so maybe that was a mistake. So let's roll forward to v5 even. So applying v5, it's pending, and boom, pods start a bit quickly here. So now v5 came up online and faster than we could know v2 was garbage collected because it rolled over to v5. The nice thing here I would quickly like to highlight is something that is incredibly helpful for somebody checking out this cluster. So I now see here I had 5 rollouts, and I can check back previous package sets and see, okay, so this is archived and it doesn't have a succeeded condition. So it never became ready. So I know this was a skipped or broken release in the chain. I check back with a revision that actually worked. Then I see, hey, nice. This rollout succeeded because it was available at least once. So I know, okay, there's obviously still some uncertainty whether this release didn't get OM killed down the line or something like that. But at least I know this should work, maybe. It worked some time ago. So it might be safe to roll back to this revision. So that's the simple thing, or the basic facilities that are
Nico, are you still there or?
Yeah, I think somebody dropped off or someone's audio died.
Yeah, it's eerily quiet from his side. Let me ping him and see. Um, so yeah, while he tries to figure this out, I think maybe if it isn't apparent enough, I think oh yeah, he's trying to join. His browser crashed. But I think so far what he's been talking about, it sort of sounded interesting to me in the Ruckpack world, because I think a lot of those concepts can be thought about for the new world. So I think he talks about a lot of interesting concepts like availability when you're trying to upgrade. In the current OLM, I think we don't do that. We just apply the CSVs and then we hope that that comes out. But the current version is already gone. So that's one thing. He talks about rollbacks. I think that's something that you constantly see operator authors asking for, or even customers asking for an operator to be rolled back to a particular version. I know he has a few other concepts that he talked about that sounded interesting, but.
Hey there, hope you can hear me again. Sorry,
Yeah, we can
my
hear you.
Chrome crashed right when I I'm so sorry. I have to get used to Zoom. Sorry. I came here to show memes. That's what I was saying. So Anik already started on extra features that I have. So this is kind of the groundwork that I've just shown. And the really cool part is here. Can you confirm that you hear me? I'm now a bit paranoid.
Yeah, we can.
Yes. Yep.
Okay. Thank you very much. So I showed that you run 2 releases of something at the same time, which does not need to be an operator, but well, OLM is all about operators in the end. So running 2 operators of different versions at the same time is not trivial, but something that makes a lot of headaches go away because, well, as mentioned, if something fails during rollout, it is not a catastrophe right away, depending on the operator, obviously. What if we can piece by piece switch the operands from one version of the operator to the other, and only if everything was confirmed to run nice on operator V2, we will kill off V1 in this whole chain. And I will show a demo right away. The other thing is that you can do with this approach, which will become interesting we have some operators in the pipe who have over 1,000 operands or more on a single big Openshift cluster. And if we upgrade those, it's always makes everyone involved very nervous because if the operator goes down and it's in heavy usage, then, well, service goes down. To solve that, and also some scaling issues with like vertical scaling of such operators becomes also a bit of a hassle. What if we shard things between multiple operators? So we have the operator run multiple times with label selectors, and something makes sure that the CRs are only assigned to a specific instance at any given time. Suddenly we can do very interesting load sharding things, which makes scaling and also some outage situations way more handleable. And when we think for projects like KCP, which is its own big topic, right? This might become really important because in a KCP world, we might have a lot of operands running for the same operator in the fleet. So demo number 2, and I hope nothing crashes this time because I don't want to waste your time. So coming back to the terminal, where is it? Here is it. So now I'm stepping one level up. What we just saw was a package deployment and package sets running in, a single namespace. Now, because we actually deploy an operator, we have a cluster package deployment and cluster package sets. So to quickly show what I have here, on the very left, there's again the deployment objects being watched. Wait, watch timed out. And the next tab are the sets. And on the very right, we have an handover object that I will come to shortly. Let me quickly get rid of the old thing. So clean cluster. Checking my script. Okay, here we go. I'm now installing a whole operator, an Nginx operator, because, well, that's kind of cheap. As via cluster package deployment. So again, we see the deployment progressing. It created a cluster package set, and that deployed the operator into a namespace here. Yes, example operator. And we also have a custom resource definition here now. So now comes the cool part. Let me create a few operands for the thing to manage. That takes a while because there's a built-in sleep, so it's not instant, and because that's boring to show. But on the upper right, we have this handover object, and these are inserted in the last deployment phase of the package deployment. And just showing you the two objects first, they look like this. First, I should have ordered them the other way around, but first focus on the lower object, cluster handover. What this thing is doing, it's executing a relabel strategy, and anything labeled with the label operator version and a value v0 will get relabeled to v1. And it's watching the operator version status property. So wherever you expose that in your CR. So that's something that an operator needs to implement, that it is on exposing the version of the operator on every operand for this to work. I'm configuring which API this handover object is targeting. So in this case, this Nginx API. And again, I configure a condition. So the handover knows when an object is ready after it has been handovered. So it can start with the next. And what you can do then is you can define, similar to a deployment, like max unavailable targets. So in this case, max unavailable 1 would make sure that only a single operand at any given time is being transitioned, and, well, make sure that only a single thing can go bad. Now, because what happens if somebody creates a new Nginx object in the meanwhile that is not labeled at all? That's, well, where the first object comes into play. This and naming is not my strong suit, but call it cluster adoption. What this will do is it will search for all objects of a certain kind on the cluster that didn't receive a label yet. And when it has no labels, then it will just add v1. And why all this mess, you might ask? Because if we check out the part 2, package deployment part 2, and this now gets long. So quickly checking out the cluster package deployment. What it's doing first phase, it's creating the namespace for the example operator. Second phase, custom resource definitions and RBAC, which is awfully long and cumbersome. Well, and service account, all the roles, role binding. After that phase, next phase is deploy. Deploy will, actually run the thing with the aforementioned label selector for this specific version. And after deployment succeeded, which we can ensure via the probes, there's a new phase for handover, which will create both the cluster adoption and the handover object. And what this is make sure is that the cluster adoption object, after the deployment ran through and this phase becomes active, it will label all new objects that a user creates on the cluster with v2. So the strategy here is that when a deployment occurs during the brief period, the two operators are running on the cluster at the same time, all new operands will be handled by v2 already. And at the same time, it will start a handover process, relabeling things piece by piece from v1 to v2. And the nice thing is, because all of this is handled within a phase within this package set, if the handover never succeeds because v2 is broken for whatever reason, the whole rollout would get stuck at that point, allowing you to either roll back or to change, for example, the default version of the operator that the operands will be using back to v1, right? So you keep issues at a minimum while you figure out while v2 is not working. And this is now the actual super impressive part from the demo, if I can say so. If I now patch the cluster package deployment, it will create the new package set, it will roll out the new operator, and now it will start the new handover process. We see one object has been updated, two objects have been updated, and the last object has been updated. All have been available all the time because nothing failed. And if the probes now catch up, yep, the new release was marked as well finished, and it archived the old one, so we are now running completely on v2. Yeah, and that's kind of the really nice thing in the end, that all of this kind of plugs together really neatly. And that concludes my demo. Now I have to read chat and catch up with questions. And I'm on time, which is a first.
Yeah, it looks. Thank you for that demo, Nico. I think it's really cool for me to at least see the concepts that you've discussed. I think we've already started discussing a lot of the concepts in the chat, which was what I was hoping for. And I'm sure we'll be talking about these things for the new APIs. But before we do that, maybe I'll let others kind of, if you have any questions directly for Nico about any of this stuff, maybe go for it right now.
First, I would say this is super in-depth, so really impressive. I think one of the takeaways that I have is that there are lots of different operators who have lots of different operator developers who have lots of different interpretations of, you know, how operators should work or what the API, Kubernetes API should or shouldn't do, or what guarantees they have as, you know, they traverse over multiple versions. And I think OLM is kind of stuck in the middle of all of that, which is trying to like solve a lot of problems for a lot of different people that have a lot of different perspectives. And there's probably not like a single one size fits all way of doing that unless we have like a super verbose API, which I think is what kind of you demoed here, which is that like to solve all of these problems, you kind of have to have like a lot of control over how things work, and you have to kind of expose that complexity either to cluster admins or to operator authors to be able to kind of tweak things and show them the complexity that exists for them to know that it exists. So like the example of like rollbacks, like if you're not careful, like you can roll forward to something that makes some sort of permanent change that your previous version doesn't know how to, you know, recover from. So like, who's responsible for knowing that? Is it the cluster admin who like somehow needs to know like you can't roll back, or like? So I think that's kind of the problem space that we're in, is like we're trying to figure out like what guarantees OLM can say it can make, and then design APIs around those guarantees and try to document it as well as we can.
I think you are perfectly on point with that. From my perspective, and again, you got that perfectly right, is Kube is complex. I think there's no way around that. And the ecosystem is in people's understanding is evolving so fast that trying to put too many guardrails on the APIs is just hindering people a lot. So that's why what I've kind of built is super low level and very explicit, and without any guardrails, right? You can shoot yourself in the foot very, very easily. But my understanding was that for things that make it easier for a user to use all of this, you can always build APIs on top that limit the traps, right? You can add extra orchestration and tooling to create those objects in the first place, to vet things, to give users well, flags to set, whether it's safe to roll back, whether it's safe to move forward, right? And people don't need to enable those flags if they are not ready or to do so.
Yeah, I think the overriding thing that is a takeaway for me, and this is from this demo and also just from all of our past conversations, is that like at the end of the day, the cluster admin has the ultimate authority and the ultimate control. You want the cluster admin to be given enough information and enough input that they can make informed decisions. But if they want to do something, they should be able to do it, period. So I think like that's kind of the guiding principle I think we should have for, you know, the design of the new OLM.
All right, then I will stop sharing because I'm already over my time slot, I guess. If nobody else has something that I should show on terminal.
Yeah, Nico, great presentation. I had one comment on some of the tenancy model that was sort of baked into some of these APIs around operators. I think from what we've seen in the original version of OLM, we tried to do operator multi-tenancy. You know, where you can have multiple replicas of an operator running across different namespaces. But I think the direction we're going in now with the newer APIs is to have your operator as a cluster scope singleton and not essentially allow this sort of sharding necessarily out of the box. I was wondering, you know, what the implications of like a singleton operator would mean in the context of scaling out, an operator in a high use cluster environment.
So from my understanding, a lot of the difficulties with OLM's current multi-tenancy model come from trying to run multiple major versions of an operator at the same time for different tenants on the cluster. So this is kind of for what I've proposed here is I only want to have one revision in flight at any given time, essentially. Now coming to sharding and scalability, maybe I'm not deep enough in API machinery, but I have not yet seen something that lets you easily like non-vertically scale out an operator without something like sharding, because all the caches are, well, cluster or at least namespace global, and it makes it very hard for an operator. But I think there's no technical limitation of just saying, hey, I shard my stuff by label selectors, as long as those objects are not, interacting with each other, which makes everything way more complicated. But I think a good API design in Cube should probably have every operand run in isolation by the controller, so it makes it feasible. Where I see this sharding become way more interesting or necessary is as I mentioned with KCP or something like KCP, where you have one operator that runs on level of the KCP control plane for fleet management stuff that by necessity has to touch 10,000s, 100,000s, or million of objects, and that is probably unfeasible to keep in a single instance, even with things like active standby and lead election. Does this kind of answer what I have in my mind?
Yes, I think it does. I think it's interesting because as we adopted the sort of this new approach on tenancy, I think there are some implications that we're missing that I think your perspective, seeing some of these really dense clusters, it brings up, and it's interesting. So I think we need to be mindful of that as we sort of look at migration path that we envision from the sort of existing APIs and tenancy model to the new version that we're currently developing. It's interesting. Thank you for that. Okay, so sorry, go ahead.
Oh, just wanted to, before I think we close out this, again, thank you, Nico, for this. I think we're already having a lot of engaging, interesting conversation in the chat, and I think that was what we were hoping to get out of. So maybe before we close out, we can take an action item of creating GitHub issues on Rackpack to sort of keep these conversations going so that we can keep a track. And then we can sort of, filter out what we need, what we want, what we don't want, and have all of those, planned out from the repo. That sounds good to everybody. But yeah, thanks again, Nico.
Thanks for having me.
Okay, great. So we have a little bit of time left. And so we did have on one other topic on the agenda, which was Joe with a proposal to set a valid default channel. Joe, do you think that we can get to it in the time we have left, or do we want to look at it next meeting?
Well, I mean, there has been a little bit of dialogue. I guess I'd be interested in maybe just kind of, I think Joe Langford has kind of digested this a bit, and I guess if maybe we could start and see what happens. Or Joe, if you wanted to pipe right in, we could. So if you don't mind, I'll at least get started. So let me share my screen here real quick. Let's see. And this is kind of a strange one. So, I'm not sure I'm even in the right spot, but for a little bit of history, so we've been working with the OC Mirror team and trying to understand the OC Mirror work that's going on and how we can leverage using mirroring and actually the parts of the mirroring where we are filtering catalogs using, and I think that's kind of where I landed here. So OC Mirror, as I understand it, today uses the alpha diff code that exists in the operator registry program today. So what I wanted to kind of just talk a bit about was what is the problem that we were looking at originally, right? I'm not sure everybody knows what OC Mirror is. I hope most of you guys are somewhat familiar with that. So the scenario here is, we have a large catalog, has every version of all the products in it. And we are looking at the ability to subset that. So in this example, there's an image set configuration, which is the input to the OC Mirror process. And I'm saying I want to filter a catalog, and I want the package, I want this package, and I want these versions, the min and the max version. And it so happens that in this catalog currently, there is also a max version that's 1.8 something. And the default channel that exists in here is that 1.8 version. So with the tooling that exists today, if I wanted to take this catalog, apply these rules to it, and I don't know if you would call this definition here a veneer or not, but I'm saying this is what I want my new FBC to look like. I want it to have IBM MQ with these things in it. Currently, this default channels is an issue, right? So we filter it out, but it doesn't adjust the channel, the default channel. That the default channel in the new FBC doesn't have any bundles on it, so it's not a valid FBC at that point. So that's the issue that we were trying to figure out how to address. And the idea was to potentially set a property on a channel, or some kind of a way to figure out, how do I set this new default channel if things get filtered out and I end up with an FBC that's not valid. So given that and some discussions with the OC Mirror team and Boo and company, we tossed around this idea of, adding a priority to a channel and then being able to have the diff code use that priority to resolve this type of a situation. So with that, I think Joe, you kind of talked about, maybe this doesn't actually belong in the FBC world or in the the operator registry project. And as I understand it, there's things maybe changing where this code that is in this POC that modifies diff, maybe this code is moving into the OC Mirror project and that sort of thing. So maybe with the time left, Joe, if you want to give me your view on that a bit.
Yeah, so I think, as we had this discussion back and forth, I think at least where I land personally is that like the core operator registry picture of FBC is like fully declarative, right? So like, at least in that sense, like it doesn't really make sense to have a priority list of channels because like, well, of course you have your default channel and you've declared, your list of channels, and of course that needs to be there. But if you're looking at this from the perspective of veneers, then I think it makes total sense, right? Like, a veneer is basically just anything that takes, anything that produces a valid FBC. And if you want to write a veneer that takes FBC as input, filters it down, and produces a valid FBC as output, and you need, that FBC or some other input to tell you, how to do that filtering. I mean, that's like totally one of the things that we design veneers, or the concept of veneers, to cover. So I think just in my mind, I think probably the diff code should be moved over to OC Mirror, kind of just as like a library that the image set config code uses, and effectively like the image set config stuff that deals with filtering FBC catalogs. That's just a veneer. And in my mind, that is totally fine and makes complete sense. And then it's just up to the OC Mirror team and the design of that image set config API to basically build out what its inputs are. And if it says like, oh, you have to have a priority property in your channel, well, if you want to use that veneer, then you've got to follow what that veneer says its inputs need to be. And then at that point, then you're kind of outside of core FBC design land, and that's totally reasonable. That makes sense?
Okay. Yeah, it does. I guess is there anything happening with the diff library actually moving there? I mean, that's why it's where I put it today, right? I mean, are they the only users of that function, the diff function today? Is that why that can be moved? Or
as far as I know, they're the only users, and that I think there's a plan to move it there. And Vu, I don't know if Vu's here, but I think he mentioned that that's on the list of things to do.
okay. Yeah, I think it gets a little more complicated because that project is moving to a new group, I guess, to the workload, the OC proper team.
Yeah, and I think I'll maybe backtrack a little bit and say that like if we all recognize that the diff code is really just a library used by OC Mirror, and right now that diff code lives in this repo, and we don't intend on promoting that out of alpha in this repo, then if we need to merge something in support of OC Mirror in operator registry, that seems fine.
Okay.
At least in my opinion.
All right. So I guess I'm not quite sure where that leaves us.
I guess I would say like as long as Vu and the OC Mirror folks review this and say let's merge it, then it'll get merged.
Oh, okay.
As long as it doesn't touch, well, I guess that's going to be an interesting question. Is it looks like it touches pieces of the model and pieces like outside of just diff that maybe we'll have to talk about.
Yeah, it does. I mean, I had to alter add the property to the channel definition and some of the schema and at least how the code's working today, kind of a thing.
So real briefly, as you're talking about veneers, did you get? I've missed maybe 1 or 2 OLM meetings. I didn't watch the recordings. Did you guys cover the next generation of veneers? Like I know you're doing the plain or the basic one, and then the Semver one. And you talked some deep dive stuff into some issues with those. But did you kind of give kind of a plan? I've seen some PRs. But it seems like there's still been some meetings or things like that happen behind the scenes, which I haven't seen. Was there something I missed?
I don't know. So Jordan can probably talk to this a little bit. He's the one kind of working on a lot of it. I don't know. I know we've been talking about it internally with our catalog pipelines because there's some specific stuff they care about related to it. But if we haven't talked about it in this meeting, maybe we should tee it up and talk about it in this meeting for the community as well. Because
I think it'd be great next week if maybe we put that up and say, hey, let's just go overview of what we're planning on doing with veneers. And then, what are the inputs to them? Because they get a little confusing for people coming into them because they look like FBCs are inputs, right? And they're basically the structure format is the input and the output is an FBC. So we're kind of reusing the same schema definition.
Like literally the input to your veneer can be anything you want it to be. So that was just a random choice we made. But you could have, you could just have a Go program that takes a bunch of flags that is your input, or you could have a TOML file that's your input, right? Like it doesn't have to look at all like the FBC schema.
Yes, that's what confuses everybody because that older HackMD document that you wrote was doing it that way, and it was a little confusing for people to understand that the veneer was really a factory for FBCs, right?
Yeah. Yeah. So, Jordan, would you mind teeing something up for whenever is a good time to present it to the community?
Yeah, I can.
So real quick, Jordan. So I know that like both of the basic and the Semver are like kind of alpha, and we're kind of really just trying to put stuff out there and see what sticks. And there's nothing like guaranteed for like what's for sure going to be there or how the APIs are going to work. Like we're going to potentially break them as we get feedback. But these are kind of our initial stabs. But yeah, regardless, I think we should talk about them and share them because the whole point is for us to get feedback about them.
Yeah, because I had put a kind of a lengthy post in the Semver one, and I think it was probably, I don't know, out of context or maybe more than what you guys wanted to hear about some ideas on how to make it a little more general purpose. Because the way the veneers are written now won't work for me. And so I would need a different way to describe some of the things I was looking at. So that's why I wanted to get kind of a bootstrap before I start inundating you guys with a bunch of maybe inappropriate things, right?
No, that's fair. I mean, the reason I didn't respond to your comment there is because it seemed like you were speaking to a future iteration of where we were, and we weren't quite there yet. So I hadn't formulated a good response.
Yeah, so that's why I need the bootstrap, because I'm probably talking out of turn.
No, not out of turn so much as from the future.
Yeah, okay, all right.
Yeah, there's a little context there, which is that like we want to try to make our operator authors conform to a more specific guardrailed terminology around fast candidate fast stable, like so that way when you're a cluster admin you know exactly what you're getting because it all works the same way. So that Semver veneer that you saw in that PR is very much like it's our way or the highway, and you like this probably isn't going to happen, but like we're going to start out with like it has to look exactly like this, and this is the only option because we want cluster admins to have this consistent view. So
yeah, okay.
Like
yeah, because that is not our use case at all, right? We don't use any of that channel taxonomy. Your best practices are not our best practices. So we have a different view of what that would be. So I kind of want to take it to the next iteration, the future, I guess. So yeah, we can tee this up for next time. We can kind of dive into a little bit more in detail.
Sounds good.
Thanks.
All right. Thanks, Joe.
No problem. Thanks, guys.
All right. Thanks, everyone. Yeah, we're quite a bit over now, so we'll cut the meeting now. This as a reminder, it's recorded and uploaded to YouTube. So.
Could you save the chat and put that somewhere too? Because that doesn't get saved at the YouTube.
Oh, okay. Yeah, I think I get the output. I can put it maybe in the video description.
Yeah, that'd be great. Thanks.
Great. All right. Well, with that, enjoy the rest of your day, and I'll talk to you. We have issue shares next week. Thanks, everyone.
Yeah,
Bye-bye.
thank you. Bye.
No.